All right, so this one, for each set of data, we're supposed to write a model for the data as given, and then a model for the inverted data. All right, so that's going to be something we have to work with. And so what we're going to do is we're going to go plug all that into our calculator. So let's clear that so we don't have to see that. Now let's do stat. And we're going to clear out that data, and we'll clear out that data. And so the data was 0, 33, 66, 99, and 132. And then this was 1, 2, 3, 4, 5. All right, now I don't know what kind of fit I need to do. So first I need to make sure my stat plot is on. It's on, and it has L1, L2, so that's good. And so then now I need to have my window though, right? So my values for X went from 0, let's go up to 140, let's go by 20s. My Y's went from basically 0 to 6, or 1 to 5 basically, so we'll do 0 to 6, and we can go by 1s even. And so let's see what kind of graph we get. All right, well that looks linear to me. I don't see any curvature. So I'm thinking that's a linear model. So we can do a stat over here, go to calc, we'll do number 4, linear regression. L1 is X, L2 is Y, that looks good. And it says it's a perfect fit. So that's what I'm going to say is my linear model, 0.0303 X and then plus 1. All right, so now let's go write that down. And let's see, what do we have here? So let's make sure we have everything in the appropriate way. So what we're getting out is pressure. So let's call that P, and it's based on our depth. So P of D is equal to, well, we found it was 0.0303 times D plus 1, and these are going to be atmospheres because that was what our final pressure was, is atmospheres. So the function P of D has to be in atmospheres. Now the question is, and that's atmospheres at a depth of D feet under, I guess under whatever, it's underwater, under the sea or under the ocean. Okay. So that's going to be our function for P of D. Now they want the model for the inverted data. Okay, well, guess what? We can do two things. Well, before we go to a different share, one thing we could do is, okay, we solve this and do the invert, find that, and we could get it directly. And so if we do that, what we would have to do is we would say, I would say y equals 0.0303x plus 1, and I would swap those and say x equals 0.0303y plus 1. So then I would take and subtract 1 from both sides, and that gets me 0.0303y. Now I divide by that, and so then my y now is equal to basically x over 0.0303 minus 1 over 0.0303. That way I can split it apart like a linear function when I get done. And then I would have to take and do the reciprocals and figure out what those are. And so let's go see what the reciprocals are. And so 0.303003, and if we take the reciprocal of that, looks like 33, roughly just 33. Okay, so we're just going to say that's 33, close enough. So it's going to be 33x minus 33. Okay. Now, what are my units now? Because now I have to think about what that is. So I have to rewrite the function now. And so now my function should be, I'm getting the depth out. So I'm going to say d of p is equal to, and now it's 33p minus 33. Okay, so that's what it is doing the longhand. Okay, and that's what my function is for the inverted data. Now let's see if we can get that a little easier without having to do all that work. Well, what we would do is we'd go stat, go over here, calc, we do the 4 again, but now we're going to switch our lists. This is going to be L2, this is going to be L1, and guess what? It says it's 33x minus 33. 33x minus 33, except our x is p and stuff, so we have to have the right units. But we have that directly out of our calculator by just switching our x and y columns and doing that. And so, our initial one and our reciprocal. All right, now we have practice though doing reciprocals or inverses. And so what are we going to do? Well, basically we're just going to do the same thing here. We're just going to find the inverse of that. So we're going to say y equals 5x plus 7 to convert it into the opposite. And then we'll say x equals 5y plus 7, solve for y. X minus 7 equals 5y, divide by 5. And so we get y equals, and then we have 1/5 x minus 7/5. And that would be what we could use. Now we have to kind of think about, okay, what are our functions now labeled as? Well, we're doing the reciprocal, so now this is really going to be, instead of f of x, it's going to be x of f equals 1/5, and then it's f minus 7/5. Okay. And we could also do just f minus 7 over 5, kind of change that. So this is, or um, the f minus 7 over 5. We could have that. So it all depends on if we want to keep it as a linear looking function, or if we don't care and we want to put it all into one piece. Okay, so either way it gives us the same answer. We could plug in f values and get out our x values, either one of those, and it's simple both ways. All right, what about this one? Well, the same thing happens. Here we just can't have t equal to 0. So let's go ahead and switch our values. And so we'll say we have y equals 0.5 plus 5 over 0.2t. Well, now I guess let's instead of y, let's call it h, because that way maybe we can keep track of things a little nicer. So that used to be h, and this is our t. So what we're going to do is we're going to swap those around, and so say t is equal to now 0.5 plus 5 over 0.2 h. Okay, now we need to solve for h this time. All right, so what are we going to do? Well, we're going to subtract that 0.5 off. So we'll have t minus 0.5 equals 5 over 0.2h. Okay. Now, because I know this is a fraction and that's a fraction, I can just swap those two values. And because if I multiply by 0.2h here and multiply by 0.2h here and divide by t minus 0.05 and divide by t minus 0.05, what I end up getting is 0.2h equals 5 over t minus 0.5. Now, to get rid of this, I can divide by the 0.2, and I can basically multiply by 1 over that. Okay. And so then I have h now is equal to, and it's going to be a 5 over 0.2 times t minus 0.5. And if I want to, I can multiply through here. This is another place where you could take 5 divided by 0.2 and get something, or I could take the 0.2 times this and get something. It all depends on what is your preference. If we take 5 and divide it by the 0.2, we get 25. And if we do that, then we'll have that's equal to 25 over t minus 0.5 Or if we multiplied by here, that'd be 0.2t, and then minus 0.1, I believe is 0.2 times, yeah, 0.1. So again, it really doesn't matter what it is. But now we have to think about, is this really what our function is? Because, you know, I usually try to swap the letters and solve for it. But if we didn't swap the letters, really what we're looking at here is our new value is going to be, this is actually became t, because if we solve this for t, that's what we've done. So this is t of h is equal to 25 over, and then we have h minus 0.5. So sometimes, you know, when we're doing these to write functions, f and f versus y's and things like that, we swap them around. But you know, this way it seems like it's better to leave it as that, solve for t, because when we get done, we actually have t of h and we have the h. So again, it all depends on how you've learned how to find inverses. I've always, you know, swapped them and then get to the end, and then you have to convert your variables back the other way. Or maybe it's better just to leave the variables as they are, get to the end, and you have your variables in the right position and you don't even have to worry about it. Okay, and again, this, you could use the 25 over h minus 0.5, or you could use the 5 over 0.2 h minus 0.1. That part doesn't matter, but make sure your function names and letters are the correct way. All right, so here we're supposed to write the sum of two functions, then the difference of the first function minus the second function, the product of the two functions, the quotient of the first function divided by the second function, and then evaluate each of these constructed functions at the 2, all right? So what we have to do here is we have to think about what all does this really mean. So the sum of the two functions. So we're going to take j of x plus h of x. Okay, so we're just taking those plus those. So 3 times 1.7 to the x plus 4x rather to the 2.5. Now, there's nothing we can simplify here, and so that's just the two functions added together. So that's all we can do for A. B, the difference. Well, okay, well, that's just j of x minus h of x equals, well, now we just have a subtraction between them. 3 times 1.7 to the x minus 4x to the 2.5. That's all we can do. Okay, what about the product of the two functions? So that's just j of x times h of x. Well, so that's 3 times 1.7 to the x, and then times 4x to the 2.5. Well, this time there is something we can do. We can take 3 times 4, and that gives us 12. And then we still have 1.7 to the x, and we still have x to the 2.5. So we could simplify there a little bit, but not a whole lot. All right, D, the quotient of the first function divided by the second function. Okay, so j of x over h of x. So that's going to be 3 times 1.7 to the x over 4 times x to the 2.5. Okay, and that's as far as we can go. We can't really simplify that any more than it already is. Now it says evaluate each of these constructed functions at 2. Okay, so that just means we have to plug in 2 here. So 3 times 1.7 squared, and then plus 4 times, and that's going to be 2 to the 2.5. Okay, so I'm just going to type this into my calculator directly. I'm not going to switch back and forth because I'm pretty sure you can type these into your calculator at this point in the game. And so 3 times that, and then plus 4 times 2 to the 2.5. So that first one looks like it's going to be 31.297 roughly. It doesn't say what place to round it to, but that looks like as good at any place, good as any to round it to there. Okay. And then the second one, we're going to subtract that. So that gives us, looks like 3 times 1.7 squared minus 4 times 2 to the 2.5. That's a negative 13.957. Okay. All right, so now what we're going to do is we're going to take 12 times 1.7 squared times 2 to the 2.5. So now we have 12 times 1.7 squared, and then times 2 to the 2.5, and that looks like 196.17, well, 180 if we round to 3. Okay. And so this one is going to be 3 times 1.7 squared over 4 times 2 to the 2.5. And so that one gives us, parenthesis, 3 times 1.7 squared divided by 4 times 2 to the 2.5. So that looks like it's 0.383. Okay, and again, we're just plugging those into our calculator, so hopefully that shouldn't be too hard, and those would be the values you get. All right, so that's all I have for this section.